In this video, we're going to take a look at the Unit 7, Lesson 11 practice problems. So number 1 says, here's a central angle that measures 1.5 radians. Select all true statements. So let's remember how we define a radian. So a radian is equal to the ratio of the arc length and the radius. So the arc length divided by the radius gives us the radian measure. And so A says the radius is 1.5 times longer than the length of the arc. And so if we kind of plugged this in here, we'd have 1.5 radians equals the arc length divided by the radius. So I could multiply the r up, and I would get 1.5 times r equals the arc length. So actually the arc length is 1.5 times bigger than the radius, not the other way around. So this is false. But B would be true, that the length of the arc is 1.5 times longer than the radius. Then C says the ratio of the arc length to the radius is 1.5. And that's true. That's the definition of a radian. So we've got arc length divided by radius equals to 1.5 in this problem. So that's true. So then D would be false because that's going backwards, radius over arc length. So it is not going to be radius divided by arc length. It is arc length divided by radius. And then the whole circle is 1.5 times the area of the slice. So this is using the idea of what portion of this circle do we have. And so let's take a look. So all the way around a circle in radians is 2 pi. And 2 pi is about 6.28. So let's see how many times 1.5 fits into 6.28. So do 6.28 divided by 1.5, and we would get about 4.2 times. So that means this is going to fit in here about a little over 4 times. Okay, so the area would be 4.2 times bigger, not 1.5 times bigger. And then same with the circumference. Okay, it is not 1.5 times bigger. We'd have to look at the portion out of the whole circle in radians. All right, then number 2 says match each arc length and radius with the measure of the central angle. And so remember that we do the radian measure equals the arc length divided by the radius. So let's take a look at doing pi over 2 divided by 2. And so dividing by 2 is the same as multiplying by the reciprocal 1/2. So for part A, it's going to be pi over 4. So that would be number 4. B, so we have the arc length is 2 divided by the radius of 3. So that's 2/3. So that's number 2. Number 3, so we would do 2.8 divided by 3.5. And you're going to get 0.8 for this. So that's number 5. D, so arc length 3 divided by radius 4. So 3 divided by 4 is 3/4 or 0.75. So that's number 3. E has pi divided by 5. And we see that in number 1. So then there's must be a repeat answer. So for part F, this one is doing, let's see, 4 divided by 6, okay, which is 4 over 6, whoops, which simplifies to 2/3. So that was again number 2. All right, number 3, Han thinks that since the arc length in circle A is longer, its central angle is larger. Do you agree? With Han, show or explain your reasoning. So remember that if we're looking at theta in radians here, remember that you can define the radian by doing the arc length divided by the radius. So if we look at that here, 6 pi divided by 15 pi, both of those divide by 3. So this would simplify to 2 pi over 5. And if we look at finding the angle measure here, we would again do the arc length 2 pi divided by the radius 5, and we see that they're the same size. So it's just getting proportionately bigger, but the angle is staying the same since the ratio of the arc length to the radius is equal. Number 4. So we've got circle B is a dilation of A. So A is the original, B is the new one. So what's the scale factor? So take the image divided by the original. So 2 divided by 4 gives us 1/2 as the scale factor. What is the area of the 15-degree sector in circle A? So we can calculate this area. And we've got 15 degrees out of 360. And then times that by the area, by the total area. So that's going to be pi times 4 squared. And so that 15 over 360 simplifies to 1/24 as a fraction. And then we have times 16 pi. So I'm just going to simplify that over here. So we have 16 pi over 24. And both of those divide by 8. So this would be 2 pi over 3 units squared for the area of this slice in circle A. So then we can look for a slice in circle B. So the area of this slice in circle B. So again, 15 over 360 is going to simplify to 1/24. So let me just put 1/24. And then times the area of this circle is pi times 2 squared. So 1/24 times 4 pi. So we would get 4 pi over 24. Both of those divide by 4. And so we would get pi over 6 here for that area. And then what is the ratio of these areas? So we want to divide them. So we're going to take 2 pi over 3, and then we're going to divide that by pi over 6. So ratio means dividing. And then dividing is the same as multiplying by the reciprocal. So I'm going to change this to times 6 over pi. These pi's will cancel, and you'll get 12 over 3, which gets you 4. And I did this backwards. So I did the bigger one to the smaller one. So I figured out going this way is going to be 4. So if we went backwards this way, it would be 1/4. So the ratio of the areas would be 1:4, or 1/4. So how does the ratio of the areas compare to the scale factor? So the scale factor is 1/2. So 1/4 is 1/2 squared. So it's your k squared value. It's your scale factor squared. All right, number 5, Priya and Noah are riding different size Ferris wheels at the carnival. They started at the same time. The highlighted arc shows how far they have traveled. And so how far has Noah actually traveled? And so Noah's traveling along this arc here, right? So we want the arc length. So we're going to be looking at how far Noah has gone out of the total. So he's gone 135 degrees out of 360. And then we're doing that portion of the total circumference. So then 2 times pi times the radius, in this case 15. And so we can multiply this all out in our calculator, and we would get that he has traveled 35.3 meters. And then Priya, so how far has Priya traveled? So we would do the same idea. So Priya's gone 135 degrees out of the total 360. And now we'll do the circumference of her Ferris wheel. And that is 2 times pi times the radius of her Ferris wheel is 30. So when we multiply this out in our calculator, we'll get about 70.7 meters. So if the Ferris wheel will each complete one revolution, who do you think would finish first? Okay, so who do you think, so if the Ferris wheel will complete one revolution, who is going to finish that Ferris wheel first? They've traveled this far in the same amount of time, okay, then it would stand to reason that it will continue to turn at the same rate. So when they get finished, when it does one rotation, it should be finishing at the same time, even though one is traveling a much further distance. A circle has a radius 8 units and a central angle is drawn in. The length of the arc defined by the central angle is 4 pi. Find the area of the sector. So let's just draw in a sector. It won't be drawn to scale because we don't know how big the central angle is, but I like to draw it anyways. And so this arc is 4 pi. The radius is 8. So let's go ahead and determine the area of this sector. So first we need to figure out what portion we're working with. Okay, and we know the circumference here, or we know the arc length is 4. So let's find the total circumference, which would be 2 times pi times the radius of 8. So our full circumference is 16 pi. So the portion of the circle that we're working with here is we've got 4 pi out of 16 total pi units. And so then this 4 over 16 simplifies to 1/4. So we're working with 1/4 of the circle. Okay, so definitely not drawn to scale. 1/4 of the circle looks more like this. Since we know 1/4 of 360 is 90, so we'd have a picture that looks more like this. And then if we're looking for the area, okay, so now when we do the sector area, we want to do 1/4 of the total area. And the total area is pi times 8 squared. So 1/4 of 64 pi. So that arc length, 1/4 of 64 is 16 pi, and then units squared. Number 7, Claire is trying to explain how to find the area of the sector of a circle. She says, first you find the area of the whole circle, then you divide it by the radius. Do you agree with Claire? Explain or show your reasoning. Okay, so we're not going to divide by the radius. You want to divide by how many pieces. So if we wanted to do this, okay, and we had this circle split into equal chunks, we wouldn't divide by the radius. We would want to divide by the number of chunks that there are. Now, those aren't obviously equal, but we would want to divide by how many slices there are. Okay, so divide by number of equal slices, not how long the radius is. All right, so for 8, it says line BD is tangent to the circle. So we've got BD here that's tangent to the circle, and it's tangent at the diameter. So here's the diameter. List 2 right angles. So what 2 angles do we know are right angles? So if AB is a diameter and BD is a tangent line, they are going to be perpendicular to each other. So angle ABD would be one right angle. And then since AB is a diameter, it's splitting the circle into 2 180-degree arcs. So we see that this arc right here is 180. So the inscribed angle coming off of it would be a 90-degree angle. So angle ACB would be 90 degrees as well, or a right angle.